Hello Sparkers, this is Instant Kafka. Today I want to talk to you about a tile on there that I don't think gets nearly enough use, and it's called the sample noise tile. And a lot of people think it has something to do with getting random numbers, or maybe even something to do with sound, but neither one of those is correct. It's not for random numbers, and it doesn't have anything to do with sound. The noise function allows you to create stuff that looks random, but in a smooth or fairly consistent way. It's used a lot in texturing to make textures look interesting. And you can see just by searching on the Google Images for Perlin noise, all these different interesting images that are created with the noise function. Oops, sorry about that. Right here, this looks like it's creating surfaces for planets. It's pretty cool. Another planet surface one. This looks, I don't know, like, it kind of looks like hair or sheer fabric. Looks like lightning. Minecraft. Minecraft uses the Perlin noise or a similar function to generate all its biomes and make it look random, but it's not random, and that's a key feature of sample noise because it's based on it samples based on a position, a vector position, either 2D or 3D position. So every time you go to that position, it'll have the same value, and that's why it works for procedurally generated worlds like Minecraft, is because you turn around and then you turn around again to your original view and everything's going to be the same, and it's because it samples the same values based on the position, if that makes sense. I'm not a mathematician, but trust me when I say that if you go to the same position, it's going to have the same value there. But it seems to be random because it looks randomly distributed over distance, like this one right here, like these. And that's why it's so handy to use in a procedurally generated world. Here's a good example. Now, if this view was moved so that all of this was completely off the screen, and then it came back, it's not storing all these positions in memory. What it's doing is it's just sampling from the same positions and getting the same values. I don't know how else to explain it, but that's how it works in Project Spark as well. And I can show you that go in here and modify the default character a little bit. We don't need to show the display, the health meter. We need to move. We don't need to jump. Well, we can jump to show them that. No, let's take that out for now. We don't need to attack or shoot or detect interactables. Okay, so we just want to move around. And the only other thing we want to do is display. Actually, let's give it a value first. Let's assign it to a value. My noise equals sample noise at my position. That's all it takes. It has other modifiers, but really all you need is position. And really you don't even need that. All you need for sample, it says returns a random number value. That's not true. Even this isn't correct. From a range of numbers, useful for adding slight variations to an object's movement or path. It seems to be random. It's a pseudo-random number. It's not really random. Because if you give the same position, okay, if you don't give a position like this, it's going to use the object's current position. So let's do that first. Display my noise. We want to do top center. Let's just do it above. Just keep it above the character for now. So now it's at negative 0.1831. Okay, we move this around, and you can see that it seems to change randomly. Now, if we go in this direction, it's not increasing or decreasing in a predictive way, and it's always between -1 and 1. I don't know if you can see that. But here's the thing. If I can somehow, let's see, how can I do this? Let's grab the anvil. Does it have a default brain in it? Nope. So, if A is pressed, if we press the A button, we want to store our current position. All right. Then we want to move this guy somewhere randomly. Position equals random vector in a circle, radius 10, and anywhere inside that circle. And here we have to change this variable type. It's not a number, it's a vector. See if that works. Did not. Because we need to say position plus there we go. All right. Now, if we press the B button, we're going to put it back in its original position. Okay. So we did that. It goes over there. We press B, and it goes back in its original position. A, B, A, B, A, B, A, B, A, B, A, B, A, B. Okay? Then what we're going to do is take the same code for reporting the noise, put it in here. Okay. Now, take note of this number. It's negative 0.2792. Okay? We moved it to negative 4692. And then B to go back, negative 0.2792. See, it's the same number. It's based on position. Go here, go back. Go here, go back. Go here, go back. Take note of the number above the character's head, negative 0.1831. Right? Oops. It's the same number, negative 0.1831. Now, move this guy. Started. Now it's negative 0.5201. Restart. Negative 0.5201. And just so you don't think it's the old bug with random seeding, you know, with it always being the same number, random number every time, we'll make this guy a template. Logic cube. And here we're just going to continuously get a random number. Random equals random number. And then we're going to say display text. Press A to begin. Then when A is pressed, we're going to create that guy. Oops. Just create it at the position of the logic cube. See if that works. So press A to begin. Now it's 0. After it settles down, it's 0.2024. Restart. We got random numbers going right now. 0.2024. Right? That's just to show you that it's not random, it's position based. And we still have with this going on. There it is. Okay. Negative 0.2792. Random. Oops, that's probably not good. Anyways, 0.3139, and then it goes back and it's 0.2792. Do again. We'll get 3 guys in here now. Back 0.279, negative 0.2792. I just want to illustrate that the sample noise is not a random number. It's a pseudo-random number. And if you could map, if you could change the color of the terrain where this guy walks as a scale of gray from white to black, according to the sample noise, you would see, after he walked around for a while, the image would, where is, I can't get to it. The image would end up looking something like this. Like this. And we can sort of do that. Let me get comfortable here in my chair. We can do that if we, let's get rid of all this stuff now. Let's get this guy. Put this guy back. It's a non-template. Delete this, delete that. Okay. Now, what we want to do is create a grid. We're going to do a mini version of something like this. Actually, let's not use the logic cube. We don't need to have all the graphics on it of the head. Let's just use a cube. Primitive cube. Okay. Now I can go in and write some code to make a grid of this, but really, let's just do this. Oh man, why did I do that? Okay. Alright. Let's do this the old-fashioned way, and we'll just make a grid. Oops. Let's not do that yet. What we want to do, in here, once the first is created, we want to set the solid color. Now, because this is an issue with sample noise that I've noticed. We go back to here and we watch this. It goes from, seems to go from -1 to 1. I can see like 0.6 in there. I can see some -0.4s, 0.7s. It never quite gets to -1, and it never quite gets to 1 all the way up. It gets close. I think the highest number I saw was like 0.998 or something like that, at -0.998. But it never gets quite there. The problem is the sample noise says it returns a random number. That's the first problem. It's not random. A pseudo-random number value from a range of numbers, useful for adding slight variations to an object's movement or path. Okay, that's great. But it has a modifier in here that seems to be to tell the sample noise to get a number between -1 and 1. If you put that on there, it doesn't really do anything different. See, it says 0.8 in there. I never see it actually go up to 1. Now, you can check that. If we have a minimum, if we keep track of the minimum and maximum values, min equals -1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if that's even a number, but okay. And we have a max that's equal to a new number. It's the same thing, only positive one. No, I want this to be the max. I want this to be the min. New number. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh, whatever. It's not going to get that high anyways. I'm initializing these to ridiculously low numbers for the max and ridiculously high numbers for the min, because in here, once I find this noise value, I want to check for minimum and maximum. I want to check it against the minimum, current minimum and maximum, to see if it needs to be the new minimum or maximum. So if my noise is greater than max, then this current value becomes the new max. If my noise is less than min, then this will be the new min. Alright. This is going to keep track of the absolute lowest value and highest value we're getting in here. Now we can change this. Let's keep that. Plus text max plus max plus text min plus min. We'll close it off with parenthesis. Text, new text. Okay, so we're going to get the current value, and then in parentheses we're going to have the max and the min value. I think this will work. Yeah, there we go. Alright, so we can see the minimum value is -0.0 or -0.9388. Let me jump around. I can't jump around, but no matter where I go around here, the max is 0.936. Oh, it just changed again. 0.9424. No matter where we go around here. My point is, this never quite gets up to all the way up to 1 and all the way down to -1. My other point is, the way this works, this is useless because it's already by default going from almost -1 to almost 1. That has absolutely no effect. There's a 0.9157. And when I first started using this, I was expecting to get a value from I was expecting to get a value from 0 to 1 by default. That's more handy to have. This is not so handy. -1 to 1. So we need to map the -1 to 1 mathematically back to 0 to 1. So in here, we need to get my noise first. My noise equals sample noise. Then we're going to change that value, which has a range of almost -1 to 1 to 0 to 1. How can we do that? -1 to 1 has a range of 2, I believe. -1 to 0 to 1 is 2. -1 to 1. We want to change that to 0 to 1, which is a range of 1. So the first thing we need to do is add 1 to it and divide by 2. Plus 1 divided by 2. Let's copy this to this guy. We'll ignore this one. We'll keep it, but we'll ignore it for now. We'll paste that in there. Okay. So now we should get a value. That's weird. The minimum. That's not quite correct either, but the max is working, but oh, there we go. It is going down. Okay. That works. We still can't get quite to 0, and we can't get quite all the way up to 1, but that's good enough. So we have we've mapped our almost range. to 0 to 1. Now we can do this. We can say that the, what is it, the luminance value equals my noise. Luminance is how bright or dark the color is. 0 would be completely black, white would be 1. 1 would be white. If we change my noise just to kind of inject here an artificial value of 1, it should be white. And it's white. We inject an artificial value of 0, and it's black. Okay? So now we have the shade of that block is going to be representative of the value of sample noise at its position. Okay? Now, that's great. Okay, so we get one block, one color sample noise, but here's the interesting part is if we start copying this, okay, my grid's on. Let's copy this before we really get ourselves into trouble here. Copy this page, put it in this brain, paste. Okay. Now make sure this brain is a template. True. Call this, I don't know, cell brain, grid brain, block brain, whatever. Okay, that's got our behavior. Oops. Okay, now in here we're going to say once push brain objects world picker block brain. Okay, get rid of all this now. Copy this. Thought I'd save some time by doing this, but I probably could have coded that up faster as a grid. Alright, there we go. Now we have our grid. And as you can see, they're all different shades of gray. Wow. Fascinating, right? Okay. I should have made these. Okay, let's. What can I do here? Alright, that wasn't so cool. I mean, that's fine, but what we need now is a way to change what vector, what position this is actually sampling from. We can do that by creating a vector called sample position equals 0. No, we don't want to use 0. Let's use position. Let's use this guy's position. And here, sample position. Okay, then now we're specifying which position we're going to sample the noise from. Ah, it didn't work. What's broken now? that's interesting. My noise equals sample noise, sample position. Plus my position. There we go. That's what I need to do. Not my position, but my actual position. Okay, there. What we needed to do was add the value of each block, which is the current position here. That's going to be the position of each block. So we add that to our initial position. Okay. I wonder why it didn't work here, though. That's kind of interesting. Sample noise. Yeah, good. It works. All right. Now, we got that going. Now, the interesting part... Actually, you know what? Let's do something even more interesting than that. Is we are going to... create a global object variable called player, the player, and set it to this character. Now we can take this guy's global no player position. Oops, that's right there. Global the player position plus each block's position. Okay. And we don't do this just one time, we do it continuously. Oops. There we go. Get rid of this display now. Now, what's interesting is when we move, things change. What's really interesting let's see our position. All position equals position. Then when B is pressed, rest position equals old position. Now, if you kind of look, I should probably get closer to this so you can actually see it happen. All right. Try to remember what that looks like. We got, okay, we have a couple of white blocks towards the bottom left corner there across. Then we have kind of a middle gray and a dark gray right in the corner, and then another white one, you know, off on the left. Now we move around here and we try to come back here, and we can get back by pressing B, and you'll see that it's the same pattern. Move around, it's the same pattern. And you're thinking, well, how does this help me? Well, there's another modifier with this sample noise. Modifier is the frequency. And if you crank this way down to a very small number, let's try 1.15 first to see if we can get something more of an interesting pattern. Now when we move, you can see that it moves along with it. Go over here. Now, if you can imagine having an entire terrain built up like this, where you're moving just the camera, you're like zoomed in on here, and you're just moving, you're changing a vector variable, but you're not moving anything. And it's scrolling the terrain, you know, past the camera. Probably even get a better indicator of that by cranking it down even more. 1.05. That's what that looks like. It might be too blobby now. Yeah, that's too blobby. Come on, 0.1. Oops. Values number 0.1. Okay, here we go. Now you can see like that would be a hill right there. The hill's still there. And we go back, and that's our original. That's what it looks like originally. We move around, go back. Well, there's a nice bright ridge right there. We just went over a ridge. Move in a circle. Can you see the interesting possibilities with the sample noise now? Maybe. Boom camera ready? I don't understand cameras at all. Okay, camera gizmo. Fixed camera. Okay, this work. There we go, finally. So as we're moving around, you can see we have areas of light and areas of dark. We can scroll that off the screen. We got this nice bright hill right here, right? Scroll it off the screen. We come back, and there it is again. We'll keep going forever on this. But this noise value can be used as the basis for everything, because you can use it for, you know, you can manipulate that value after you have it. for colors. You can manipulate it for sizes of things or different types of like terrain. Like that's what Minecraft does. You know, biomes, different biome types. It's all based on position. Now, if they actually made it correctly to where you have a 0 to 1, it would be more handy. But really, this is a powerful way to procedurally, or have content generated in your world. And you don't have to store all this information. You can keep going forever, and if you happen to go back to the spot you started, it'll look just like it did when you started. I don't know if there's any other way to explain how powerful this is. Anyways, I hope that helps. And I hope Mescad takes a look at this and comes up with a way better explanation of it than I can. Thanks for watching.